Hello everyone and welcome to today's webinar, Learn how to mix local data with Google BigQuery. My name is Hector Takami, I work for Stambia sales team and I'm excited to be hosting these sessions. Also, I'm pleased to introduce today's speaker, Vaibhav Misra. Vaibhav is solution architect and has a great technical experience and trajectory. Today, he's going to explain and demonstrate how to harmonize data to the cloud using Google BigQuery towards local infrastructure in real time. I would like to encourage you to share this webinar with your business and social networks. Also, at the end, we will share some common questions that several clients have been asked with the idea of generate great knowledge of our solution. If after listening the answer to these questions, you have a specific one, please do not hesitate to contact us via email to give you back the answer. Let me tell you that we are software manufacturers and we are agile, flexible, and new generation data integration concepts for vertical market. We are an expert company in data integration and we only do that. The team is made up of data experts. We're a self-financed French company. We're in a very interesting growth due to our presence in Europe, Asia, America, and Latin America. We have proven serverless technology using ELT concept that operates on more than 200 customers. Stambia's DNA is based on giving business value to our clients. We're oriented to provide innovation, implementing and understanding the most valuable use cases. By example, reducing costs, having data on time, improving performance on digital data initiatives, among others. Okay, I'd like to kick things off by starting reviewing today's agenda. We will check a brief introduction of Google Cloud Platform. Then we will check what challenge does data integration pose. After that, we'll see concept and practical demonstration of Stambia. And later, we will check the question and answer section. Okay, talking about the platform Google BigQuery, or named also GCP, Google Cloud Platform, has quickly established itself as a complete platform for deploying applications in the cloud through its Google storage space and simple use of technology. BigQuery is Google fully managed service, petabyte scale, low cost for analytics and data warehouse initiatives. There is no infrastructure to manage and you don't need a database administrator. So you can focus analyzing data on finding the meaningful insights. Use a familiar SQL and you can take advantage of pay-as-you-go model. What the experts are saying about these challenges, about this new solution in the cloud is by 2022, 70% of all databases will be deployed or migrate to a cloud platform. This trend will largely be due by a database used for analytics and SaaS model. GBQ is a solution of serverless, highly scalable and cost-effective cloud data warehouse design to help you make informed decisions quickly, so you can transform your business with ease. It's a platform easy to set up and manage. Also, manage large volumes as well as low volumes. This gives you the scalability and performance. Maintain SQL for as long as you have the ability and manage NoSQL. Complete infrastructure from storage to algorithms. As we mentioned, the Google Cloud Storage, the machine learning, and is able to make your backups. Convergence of data warehouse and data lake. But despite their appeal, the switch to this type of cloud platform can generate questions and some challenges. The first challenge that we can start talking is the data migration from information to on-premise. So when we talk about how to migrate information or existing data from on-premise mode to the cloud, this is something that we need to consider, and how to migrate existing data flow to the cloud. Next challenge is when we are thinking to generate the construction of a data lake, is we can observe three specific phases when we industrialize the construction of a data lake. The first one is the injection of the data and from all the possible manners. Think that we have raw data coming from various sources in streaming, batch, or micro batches. One phase, preparation, cleaning, and control raw data in order to create a data model clean and consistent, homologated. And finally, applications being able to optimize the performance of its performance cleaning data models specific for each application. The challenge is mixing the relational and the hierarchical information. The question arises of how to take full advantage of performance and feature offered by our cloud platform. One example concrete is or are issues when we develop one-way flows or data integration for relational and hierarchical mode, respecting all the good practice of Google BigQuery. And finally, the cost is important. Control the cost of the cloud. It's fundamental to control the cost for a cloud platform. The costs are related to the use and the power of treatment. Is in this case how to manage the data transformation to control and generate better costs of cloud use. Additional, we need to decide the technology to be used, ELT, ETL, manual scripting. With this, we are arriving to the main topic and start focus on the road that will benefit anyone who consumes data inside or outside of the organization. Okay, now Bebab Mirra will show us key concepts of Stambia technology, and after this he will make a quick demo mastering these challenges and showing how to integrate GBQ with on-premise data. So I pass the mic to Bebab.
Sure, thanks Hector. So in the next part of the webinar, what I'm going to do is show you the concepts of Stambia really quick, and then move on to the demonstration where I explain you the use case and we conduct some sort of executions and see how Stambia works. So the first concept I want to discuss is the fact that when you are setting up your Google Cloud Platform and want to ingest all the data, the traditional tool that you will choose comes with an execution engine, or you can say a transformation engine, which is a proprietary engine that comes with the ETL tools. And it gets very difficult to actually decide where to place this engine. And if you place this engine on cloud, on premise, anywhere, then you have to have some hardware to support it, cores and CPUs. When we move to Stambia, it's a very simple architecture. It doesn't need any proprietary engine. Stambia, makes the platform work for the data ingestion. So it will be using the underlying capabilities of the architecture that supports it. And therefore, you can place Stambia runtime, which is a small component, anywhere on premise, on cloud, or in a hybrid manner. The second part comes when you have to design all your data mappings, pipelines. So what Stambia gives you a universal data mapper, which is a simple GUI to use. You don't have to create process flows step by step, writing code at each and every point. Stambia is the approach that Stambia follows is quite simple. You have a universal data mapper, which is a high-level mapper. You have a template that supports all those complications and complexities. So once you execute this, Stambia will then, using those specific templates, let's say in this case for BigQuery, it will use those templates and then lay out all the steps based on the instructions you have provided, and the code will be generated. So if it is a pure BigQuery code, it will be using the template for BigQuery. If you are using Spark, it will sort of use the Spark template to create the or generate the Spark code. So all in all, if you see, you are controlling cost using these two concepts. You are not worrying about hardware specification for the ETL server, and as well, while your users are designing your mappings, etc., you are not wasting too much time going into the complexities of the underlying technology. So with that, let's quickly also understand the architecture of Stambia. Let's see what are the components. There are three key components in Stambia. The first one being the designer. So the designer is the whole and soul when it comes to managing your metadata and designing your flows using mapping. And then setting those flows and the end-to-end sort of execution in a process. So all of the work that you do would be done on the designer. It's a Java Eclipse workbench and pretty simple to use. And when your teams are working in a project, you can plug in any standard versioning server into your designers and start using it. The second component is the execution engine, which is the runtime. So Stambia runtime is a very small Java component. As mentioned previously, this runtime won't be processing any data. This runtime would be launching executions and collecting logs of those executions. And it will then delegate everything to the sources and targets and the underlying native architecture. This runtime, you can have a development runtime, you can test your jobs, and then you can put a production runtime. And this is where you can decide, okay, I want to keep the one runtime on premise, or I want to completely move that runtime to cloud, or I could have a multi-cloud or a hybrid architecture as well. To manage the operational part, the DevOps part, where you deploy on several runtimes, you put some configurations, etc. There's a third component, which is production analytics. Using this, you can have a setup where you have a runtime in production and you deploy all your packages, the designs that you have made, and then during the execution, the runtime will then sort of delegate everything that you have designed on the underlying architecture, be it Kafka, Spark, Google Storage, or BigQuery. It will start generating those codes that are required. So this is pretty much the architecture of Stambia. So let's start with the demo that is based on sort of a digital music store where you have an e-commerce website. And to support that e-commerce website, you have two databases. One is a CRM database, the other is a product database. And what we are doing here is with using Stambia, we are going to do some design. So the designs are already made. We are just going to walk you through how simple the setup for ingesting data from a CRM database, from a product database, from an e-commerce platform, and then how you can sort of work with the hierarchical data inside Google BigQuery. So pretty much the end-to-end picture looks like this. We ingest the data from CRM database. We bring all the album details. As you can see, in an album, there are hierarchies. So in an album, you have those details, artists, and then tracks, and tracks could be under different playlists. So it's a hierarchical data. And then from the e-commerce website, you are going to get all your invoices of the purchases that have been made for those tracks. And using all this as a staging data, then we create the entire order summary, which then can be used, you can imagine, for a downstream system, maybe for analytics, maybe a BI tool could pick it up, etc. So I will quickly move to virtual machine. So this is the Stambia designer I was talking about. This is the workbench where you set up your metadata. You can create metadatas, connect to technology, create a mapping, and create a process. So what we are going to do is we're going to quickly take a look at the metadata that we have inside Stambia Designer. So we have a bunch of files that we would be dealing with. Then we have the Google BigQuery metadata, and we have all the tables and the structure inside Stambia. So you can quickly reverse it using the wizard. It's a quite simple wizard where you have to get connected, providing the JDBC URL, and then sort of reverse engineer all the structures. So, and then you have the Google storage and some of the source tables that we mentioned. So what I'm going to do is I'm going to first execute the initialization of the CRM tables. So the first one is an employee table. So as you can see, we are joining the employee source and customer source table, and we are loading using the BigQuery template. So this is the integration template. We are going to append this data, and we are going to use a storage. So that's our first mapping that will get executed, and the second one would be the customer mapping. As you can see, apart from loading the data with some minor transformations, and the loading happens in stream, and this is the particular template for loading that data. And then comes the part that we are also having an error capture step, where if we if you receive a invalid postal code or an empty postal code, it will reject that request. So what we are going to do is we are going to execute this, and then with Stambia, the best part is while the execution is running, as I said, the templates comes into picture, so you can go inside each template and follow the execution, and you can check the kind of code that is being executed by Stambia, the scripts that are written, the Java APIs that have been used. So you have a clear picture of what's going on inside a particular mapping and behind the scenes. So you can control that in the templates. You can also decide to customize those templates that are being used by these mappings. So as we can see that the load template of employees have been completed, and the customer data has been loaded. You can quickly verify. Let's quickly verify that data. So I have this particular schema here, and I will refresh this. As well, I have a bunch of buckets that have been created. So this is the work bucket where we are, every time a cloud storage is being used, the data would be going through this bucket. And so we'll just quickly take a look at the table that we have loaded. So employee table has already been loaded, so we can just quickly preview the data, and a bunch of records have been loaded. As well, I'm guessing the customer data is also loaded. So you have the customer and employee data loaded. So again, the designs are kept pretty simple. The templates do all the job. The next part would be to load all the album details. So if I have to open this mapping, as you can see, all the album details are being collected by joining a bunch of tables. You can take a look at the join conditions between all these tables and the tracks and the playlist, etc. Finally, you can just drag and drop into the hierarchies. So you don't have to really think about how to design a code or something. It's as simple as a file to table for us, or a table to file, a very simple mapping. And Stambia's template for this, which is the load RDBMS BigQuery, will do the entire job of handling the hierarchies. So what I'm going to do is I will execute this as well, and it will extract all the album details, and it will load it into the BigQuery target. So we can verify that on the BigQuery side as well, and see how the hierarchies are loaded. Right now, it's still in execution. So once this execution gets completed, again, you can go inside. The loading part is done, and now it is integrating. That also is done. So now we can check the data available, and it should give us the refresh data. So you can see that all the hierarchies now are available, You can see a particular artist has maybe several songs, in this case one song, but then that song could be appearing in multiple playlists, and therefore you have those hierarchies now created inside BigQuery. So that's the first step. So where we are right now is we have loaded the customer and employee data. We have loaded the album details and everything. The next step would be to bring the invoice inside Stambia. So what we are going to do is next thing what we are going to do is we are going to generate invoices. So because this is a mock of that e-commerce platform, we are going to simulate that the invoices are getting created. So we have written a very quick template, which if I execute, it will generate an invoice. So what we are going to show you is the streaming process. As and when the invoices are created, we are moving that into BigQuery. We are joining the whole data with other staging tables, and then finally we are creating the entire order summary. So I have created an invoice, and let's take a look at that invoice. So what we are doing is, in this particular incoming folder, we have that invoice sitting in the cloud storage, and this is the invoice which if we see the metadata detail of this particular invoice, it is tagged as new. So this is the property we will use, because in a streaming environment, you can imagine there are multiple invoices coming. Which one Stambia is processing and which one is a complete new, we should have a tag to that. So we are using this property in Stambia. Then the next part would be, so this is the breakdown of the entire streaming process. So I will execute this and it will sort of change the metadata to in progress. So now again, if I go and check the metadata, I have this in progress. This is just so that Stambia doesn't misses any file, or is not the action is not duplicate or redundant for the same file again and again. So now that we have set the in progress, now we are good to go with loading that invoice. So I will execute this load invoice, and we can quickly check this mapping as well. And when we see we have the JSON format of the invoice in Stambia, you can see we are joining that to our customer table that we have loaded, the album tracks table that we have loaded, the employee table, and then finally we are creating a sort of a entire order summary, which again is a hierarchical format, and you have the entire order summary of that. So I will close this, and hopefully, yes, it has been loaded. So we can quickly check how the order summary looks like in the BigQuery. And when we go to the order table, you will have that one record, because we have just processed only one invoice file. So you have the entire details around that particular invoice, and you can see that the hierarchies are maintained, and you don't have to do a lot of coding, or you don't have to set up a very complex process step by step. It's just Stambia templates that are doing the job and handling those complexities. So the next step, because we are in a streaming process, we will be getting invoices after invoice, so it is good to archive them. The moment it is processed, you move it to archive. So I just quickly execute that archive part, just so that when I go back to my data, I don't have anything. Earlier it was AMI records, and then inside that there was a container or folder called incoming. So I don't have anything right now. So this is the breakup of the entire process. So what I'm going to do is to have the streaming process running, what I'm going to do is, I have already a load invoice. I have a cron for it, which I have paused. I will resume that so that it starts getting into action, and keep checking whether I have received an invoice or not. And now what I'm going to do is, I'm going to simply just click on generate invoice, And this process, what it will do is it will start generating invoice after invoice after invoice, sort of a simulator, as I said. And now Stambia, all those mappings that I have shown you step by step will start running in sort of a stream, and start collecting those invoices. So let's just quickly refresh this bucket. And as you can see that this is a folder, and this is the incoming, and then you can see that the moment you refresh, these invoices will start coming in, and Stambia will start picking those invoices and start loading it. So you can see that the invoices are getting generated one after the other, and the list will start increasing. And in BigQuery, now if I sort of refresh the orders, I come back to the orders. Now I will see a couple of more orders that have been created. So I think I will keep refreshing this. And on Stambia side, as you can see, this load invoice and the generate invoice is something that keeps on running. So let's quickly check whether we have additional orders getting loaded into BigQuery. So you can see that I have now 11 pages worth of data. So you can keep scrolling, keep going to the next. So because there are hierarchies, so one record is producing a lot of hierarchies. If we go at the end, so you have so many playlists that are associated with that artist and the particular song, and you can just keep browsing all that data that you have loaded right now. So all that data is being streamed, and on the bucket side, if I refresh, the list goes. The list keeps increasing because we are constantly generating. So you can imagine this is a simulator. You might not have, or you might have more than the frequency that we have kept. And then the archival process as well will be running, and your archives will see whatever data that you have processed will be archived once the data is loaded. So that archive process will also getting created more and more as and when you are loading that data. So as you can see, with a very simple setup from Stambia's side, we have just two of the processes set up. One of the process has the load invoice mapping that we have seen. It's a simple drag and drop interface where you have the metadata and you can handle hierarchical structures very easily inside BigQuery without too much without going too much in depth and getting things complicated. So pretty much what I had shown you, we have the endpoint as the order, sort of a hierarchy created inside BigQuery, and I think that's all for the demo of the use case. Over to you, Hector.
Okay, very nice demonstration, Babab, and thank you for that. And well, let's pass to the question and answer section. I have some questions that we mentioned at the beginning that we have from some common question. The first one is, do you have connectors for other cloud solutions? Well, I can answer that. The answer is yes. As you see, we have the power of the templates. We have a different way to connect sources and to extract information coming from different technology. And yes, we have several templates that can manage this kind of connectors. The next one is Stambia is an open source solution. Maybe Babab, you can help us with this.
So, yeah. So Stambia is not an open source solution. So we don't have a developer community which is contributing or something, but it works in a way that it is a more on a templatized approach. So if you own Stambia, any one of your developers or users can enhance the solution or enhance those templates. So it is open but available based on the licensing. So a small answer would be no, it is not an open source solution.
Okay, good. Next one is, what is your pricing method? Well, if we go back to the slide that Beibal was showing the architecture, we can see that we have the developer or the licenses by the developer. This is a on-premise solution, and well, is you acquire the license and you keep it as long as you want it. It's a perpetual one, and is the cost is based on that. It's not based on number of records. It's not based on number of connectors. It's not based on a number of sources, environments. So this gives you a good visibility of the cost, today cost and the future one. So the idea is to have this, keep it as simple in the side of pay for this kind of model. Okay. Next one says that what language is used to encode in Stambia?
So Stambia is a Java-based tool, and the templates that we produce generates native code. So in those templates, we are writing various kind of codes, JavaScripts, Java codes. So yes, it is based on Java, but Java is not the code that is processing the data. It is on execution. The native code is generated. For example, if I take BigQuery, as I showed in the demo, all those APIs that BigQuery provides, the Java APIs will be used and a Java program will be created. But on the other hand, if there is a database, then the loader script will be generated while execution. So at the core, it is a Java-based tool, but what you write is the script that you write is, at the end of the day, will produce the native technology code.
All right. And next one about the training. It says, how long does it take to train in Stambia? Well, I can answer this. Normally, it takes you, the training course is 3 to 4 days, complete 3 to 4 days. But let me tell you that in 3 to 4 weeks, the user will be able to start producing by themselves the flows and all the mappings, and to master in the technology. So from 3 to 4 weeks, you will be autonomous to start doing your flows. I mean, it takes you 1 hour to generate a simple mapping, and to 4 to 8 hours to generate a complicated mapping. So the idea here is to keep the things also easy for all the users. Okay, next one, it says that does Stambia has a module to manage the data cleaning process?
Okay, so yes, you have to start with, we have a reject management templates for each and every technology, and using those, the first step is to sort of reject all the records which have a particular column that is invalid or that has some error. So you can have, for error reporting purpose, you can have activate the reject template, write those rules inside your metadata, so that you are not loading a bad record inside your target database. And then the transformation that you write in your mappings is again one of the way where you can cleanse your data or have quality data loaded into the target.
Okay, good. Next one, this says we are looking for a data integration solution to make continuous integration and continuous delivery. Can Stambia meet this need?
Okay, yes, of course. I have a slide. Maybe I will point to that slide. So the short answer is yes. So we have added this feature couple of years back, and we have the continuous integration, continuous delivery, with which supports through the three key components that I showed you. The designer, production analytics, and the runtime. So you can set up the continuous integration and the continuous deployment with Stambia.
Okay, that's clear. Well, is there a demo trial version of Stambia?
Yes, of course. So there is a trial version that is available, and with the new edition of Stambia, with the latest version, which is the Stambia 2020, what you can do is, what we have added is a feature where you have inbuilt projects, so that you don't have to set things up. So you can just quickly choose which project you are interested. So basically based on the technology. So let's say you are interested in BigQuery, you will have a project. You can just import it in your workspace, and then you can configure it with your BigQuery details, user ID, password, and stuff. And then you can get started with sort of practicing or learning how to use and executing some sample mappings. So yes, that is available currently.
Mm-hmm. Next, can we create our own connectors?
Yes, there is a possibility, although what we do is, or what we have been doing in the past is, with our customers, we participate in those kind of, you can say, proof of concept, or there is a new requirement. So we engage with them, we work with them to create a connector, so that it's something that is holistic and has an optimized approach. And with the connector, there is a template also to work with the mapping. So yes, either a customer themselves can enhance it, or most commonly what we have seen is Stambia R&D team will participate and work with the customers.
Good. The last one is telling or asking, can we do parallelism, or how is parallelism managed?
Yes, so parallelism is managed natively. When I say that, it's because Stambia, as you've seen, it doesn't process any data. So the execution engine doesn't process any data. So we don't have to come up with any specific parallelism. Wherever we are loading the data, or wherever whatever technologies we are using, the parallelism, we will have the right kind of codes, right processes written inside the template. So yes, we can sort of enhance, or already out of the box produce templates which have the parallelism capability, and so that you don't have to, you can just quickly configure it through multiple options, and then get going.
Okay, we are getting to the end of this session. We have been seeing very interesting concept, considering that not all data is in the cloud, and not all data will be local, thus using the best of two worlds. With Stambia, we can help to cover these challenges. We saw the challenge to data migration from on-premise to GBQ, to standardize the construction of a data lake on GBQ, mix the relational and the hierarchical information, and control or master the cost of the cloud. In addition, having seen highly practical demonstration, even you are ready to manage your online music sales site. The perception of our technology using this example gives a broad overview of the integration capabilities of the simplicity and achieving it and manage any business to cover any need in the data supply chain for any project. Remembering that templates greatly shorten the needs of being an expert in all current technologies and accelerate the adoption of new ones, as they help in your connection from any source, also controlling the quality of data, publication and use of integrate data, and automatic generation of SQL statements. In addition to its technology without using server or serverless, delegating the transformation using the ELT concept, Also, we saw that the price is based on the number of developers and not on servers, processors, data volume, giving excellent visibility of the today cost and future one. With this, we hope to generate interest in our technology and in Stambia. We will love to hear from you and see how we can help you. I've left you at your disposal the offer of a personal presentation and then be able to scale a proof of concept. So we'll be able to know our solution in deep. I thank Beba for sharing their knowledge and thank you again for your time. Have a nice day and take good care of yourself. See you soon.